Subscribe to my channel and press the bell icon to get the notifications of the videos.
Hello everyone, this is Kartik Garg and I am back with the second part of the Python tutorials. In this video, we will discuss about Python operators. The topics of the video are arithmetic operators, assignment operators, comparison operators, logical operators, identity operators, membership operators, and bitwise operators. We will start with arithmetic operators. So let's start. 4 plus 4, we all know about addition, subtraction, division, and multiplication. We also know about modulus, or you can also call remainder operator. It gives me the remainder. If you divide 4 by 2, then the remainder is 0. If you divide 4 by 3, then remainder is then the remainder would be 4 modulo 3, that is 1. And if we talk about this operator, this is called floor division operator. It gives you, it doesn't gives you the fractional value actually. Like in case of 4 divided by 3, we got 1.33. But if we use floor division, then what will floor do? Floor will simply give me the integer that is not fractional number, that is the natural number, like this one. 4 floor division 3, it gives me 1. Actually, floor does the thing that it removes the fractional part of any number. So by removing the fractional part, we get 1 from 1.33. If the number is negative like -4, then floor division will give me -2 instead of -1. Why? Because the work of floor is that to move the particular given value to the lowest integer. That is, in case of plus 4 divided by 3, we got plus 1.33. The lowest integer is 1, so we got 1. But in case of -4 floor division 3, the quotient would be minus 1.33, but the lowest number would be -2. Minus 1.3 is greater than -2. That's why the output of floor division would be -2. Now move on to next operator, that is exponent. It gives me 4 raised to the power 3. If I want to calculate the square of 5, then I will write 5 double asterisk 2. It gives me 25. Now move on to assignment operators. A is equals to 3. We all are aware about the assignment operator equals to, and also about the assignment operators plus equals to. Now A is 3, plus, using plus equals to, A has been changed to 7. Minus equals to, A is changed to 2. If we talk about, we actually the assignment operator in case of plus equals to, minus equals to, slash the division operator equals to, modulus equals to, the floor division equals to, or exponent equals to, and all these does only one thing, that the operand on the left hand side of the operator is automatically treated with the operand on the right side of the operator as per the property of the operator. Like in the case of plus equals to, we had wrote a plus equals to 4. In this case, a is equals to 3. So it will consider it like 3 plus equals to 4, and then it will work as 3 plus 4 and return the value to a, that is a is equals to a plus 4, a is equals to 3 plus 4, and a would be 7. So if we try one of these, like what will happen, a and is equals to 2. As we all know, a is 2 right now, so let's check what will happen. A is the same. Actually what happens in this case is, it is a bitwise operator, and what it does, it converts the value of the variable to binary and then treat with the other operand by converting it to binary. It performs the AND operation on the operands. Now if we talk about a right shift equals to 2, then what will be the output? 0. Why? Right shift operator converts the given operand value into its binary form, and then it, depending on the second operand given, it moves the bit of the operand. And like if I talk about right shift operator, then we know the binary value of 2 is 1 0. In case of a right shift operator equals to 2, what will happen is that 1 0 would be treated like, at first attempt 0 would be removed and 1 would be moved at place of 0, and then at second attempt 1 would be removed and further 0 would be placed at the position of 1. That's why the answer would be 0. But in case if I have, suppose a is equals to 2 again, and now I perform left shift operator, then what will happen? It gives me 8. Why? Because in binary form 2 is 1 0, and as we gave 2, that is perform 2 right left shift operator or left shift operations on a, so it will move the bit of the given operand one by one. Depending on the number of operations, it will perform the total operations, and at the end of the operations the resultant would be the output. So in this case 8 is the output. Now moving on to comparison operators, like if we want to check b is equals to, suppose to, if I don't know what are the values in these two variables and I want to check whether they are equal or not, so I will use comparison operators like a double equals to b. Depending on the values in the variables a and b, it will give me true or false. Here it is false because 8 is not equals to 2. Now if I use not equals to b, then it gave me true because this means not equals to, 8 is not equals to 2, that is true. Now if we talk about a greater than b, then yes, it is greater than b. A greater than or equals to b, or yes, it is greater than or equals to. In this case it is greater than. If I talk about a is equals to 2, then if I check for this, then also it is true because it is both greater than or equals to. Now moving on to logical operators. Logical operators, the two operands are checked for their values, either true or false. Like in case of AND operators check both the operands for true. If both the values given are true, then it will give you true. But in any case, if one of the value is either false, then the output would be false. We can check it like that. We have three variables. Suppose a is equals to 3, B is equals to 4 and C is equals to 5. If I write a condition like A less than B and B less than C, then we can check here that 3 is less than 4 and 4 is less than 5, so output would be true. But in case if I change it like this, B greater than C, that is false, 4 is not greater than 5, so output would be false. And if we talk about OR operator, or check for any of the two operands to be true. If any of the two are true, then the output would be true despite of one of them to be false. Like in this case, this A less than B is true, but B greater than C is false, but the output would be true because it check only one for true, that is this one is true. Now not, this is what I have now and it will give me true, but suppose I want false from it, then what will I do? I will use not operator. I will write not in front of the value and then the output would be automatically false. Not gives me the negation. Suppose if I have a value that is already false, like in this case, and I want it to be converted to true, then what will I do? Simply add not before it. Not negates and changes the boolean value to different value. Now there are some more operators like identity operators. In the case of identity operators, we can check like if A is equals to 4 and suppose B is equals to 4, both are same. Now check for A is B, true, because A and B are same in the case of values. But suppose if I do something like I changed B from int to float, then what will happen? Would it be same? Let's check. False, because int and float are not the same. We will talk about the data types in the next video, so don't panic right now. Now if I write is not, that is I am checking if A is not B, they both are not similar, then in this case being an int and being a float, they both are not same and the condition is true, so output would be true. Moving on to next, membership operators. Okay, now like if I have a string of characters like this, okay, and I want to check for k in string x, then I would do like this, true. It will check the given value in a given string or any other kind of data structure that will be discussed in the next video. And if I know that suppose that there is no character y here, so if I check y in x, then it would be false, but if I check for not in x, then it would be true. Now moving on to the last operator, that are bitwise operators. So as I told you already that these three operators are bitwise operators. They convert the given operands into their binary form and then they perform the operations. Operation is similar to the logical ones like AND or. This is AND, this is OR, this is XOR, and so we should start with XOR only, but yeah, I can give you the examples. 4 and 3, this would give me 0 because 4 is 100 or 100 and 3 is 0 1 1. In so there would be no bit similar in this case, so the output would be 0 as AND check for both bits to be similar. Now If we move on to next one, that is OR, what would happen? OR gave me 7. Why? Because it checks for any of the bit to be 1, and in this case 100 and 011, all 3 bits would be turned up to 1 in case of OR, so output would be 7. But what will happen in case of XOR? So let's go to XOR. The answer is same as OR, but why? Let's take another example. Suppose we take an example of 5 and 5 XOR 3. What is the output? 6. Why? Let's check. What will happen here is that 5 is 101 in binary and 3 is 11011 actually. XOR does some different thing. It If it encounters the same bit like 1 and 1 at the ones place, then it will turn that value to 0. But if the two bits are different, like at the tens place 0 and 1, they are different bits, then it will result into 1, and at the hundreds place the value would be 1. So the output would be 110, that is 6. Thanks for watching the video. Please like, share the video and subscribe to the channel. Press the bell icon to get the latest notifications, and stay tuned for the next video of data structures in Python.